Hi, everyone. Welcome to the Hunt Club podcast. Today we have a product briefing with Dale O'Grady from the technical marketing engineering team. Dale, when you want to say hello to the audience?
Hi, Zoe. Thank you so much for having me. I'm always happy to talk to you.
Yeah. And today we have a very, very exciting topic, something that our customers and a lot of other folks have asked for, which is how Vectra integrates with CrowdStrike to deliver complete visibility across network and endpoint. So this is going to be really, really insightful conversation. And yeah, let's get started. You ready, Dale?
Excellent. Let's do it.
All right. Okay, so we're starting first with the foundation of contextualization. So when an analyst sees a network detection, the very first question they'll ask is, what system is this even coming from? So my question to you, Dale, is how does Vectra help answer that question?
Sounds pretty basic, right?
Mm,
Actually, a lot of investigations bogged down here. We've got, things like suspicious network connections and, you want to figure things out. There's a context means a lot. Is it my domain controller? Is it some random workstation? Is it another system that I care about? Really important, right? It really helps put things into context. So what we want to do first and foremost is we want to answer that question. So what we've done here is we've created some bidirectional recognition between Vectra and CrowdStrike. We both bring elements or artifacts to the table here to help identify basically what an asset is, right? So that's what we want to do. As soon as like an EDR agent, a sensor they're called, as soon as they're deployed, Vectra is going to go ahead and see those, right? So we're able to combine the information that we can pull off the wire, off the network for that asset, for that host, as well as the EDR information. So now we can show you some actual context, right? And we're not talking just the IP. This the IP address, of course, is important. A lot of networks have a lot of IPs, perhaps naming conventions that, they're a little obscure. So in this case, we're also going to surface things like the operating system, CrowdStrike sensor ID, when it was last seen, even the location. And why it matters, it's because if we have this suspicious behavior, and if it's coming from, a jump server in my data center versus someone's laptop, it doesn't mean they're not both threats, but when it comes time to triage and to respond, I need to work on the one that drives everything urgently. And in this case, that would be the jump server in my data center. So this, really helps us to identify and eliminate that research phase and answer the question, well, what system is this?
mhm. Absolutely. So now that analysts know which system with this contextualization, what's the next question, or the next question that usually analysts go for is the hardest question. So what process actually triggers this behavior? And so we have a feature that answers this question. So can you walk us through how EDR process correlation answers that question?
And this is where investigations totally fall apart, right? And they fall apart
Mm,
time. It's time is everything, especially when you mix in this volume of data. So in this case, NDR, we see that suspicious behavior, the network behavior. Maybe it's a connection to a suspicious domain or some data exfiltration, possibly, command and control. And, we could surface that, but network telemetry alone can't tell you which process on the endpoint actually initiated that. So you got this dance, right? So the analyst is going to, switch over to, CrowdStrike in this case. They're going to search for the host. They're going to look for the process. They're going to find lots of them. They're going to try to narrow it down to a time frame, correlate timestamps, which is, for horrendous for anyone who's ever tried to do that. And then they're going to hope to find the right one. This is at least 15 to 30 minutes of detective work, doing it kind of blind. So with this EDR process correlation, we want to automate that entire workflow. So when we flag that suspicious network behavior, we're automatically going to query CrowdStrike. We're going to look for that host process activity. And more importantly, we're going to analyze it, right? We want to identify the most probable process because there's multiple things happening. And with that, we're not going to give you just the name. We want to give you additional context. As we referenced earlier, context does mean a lot. What's the command line? What's the hash? What's the execution time? What's the paired process? What account did it run from? This is all very meaningful information. And you've got a great example here in the slide, where it hovers over the Microsoft Edge update.exe. It looks legitimate. It's in a Microsoft folder. It's got a believable name. It sounds totally relevant. But then that additional context, when we hovered over the command line, we can see a connect string and it's connecting somewhere really odd with this retry interval.
Mm.
That's not an updater. That's C2 beaconing and it's checking in every 5 minutes and it's running at the system level spawned by services, just so that it registers itself as a Windows service for persistence. That command line alone, that additional context along with that process information, we converted what was potentially suspicious network traffic into confirmed persistent threat that obviously requires some immediate containment. And we got there in seconds, not half an hour.
Absolutely. And you talked about processes, and I see in that GIF right there, show more processes. What does that do exactly?
Oh, that's where it gets even more powerful. So when you click on that, we see additional process activity. We wanted to hone in on the main one, what we call that probable process, but there's more to it. There's more to the attack chain. And so in this case, we can get a better picture of what's happening within the scope of that threat. And we can start putting stuff together. Just looking through that graphic, we can see along the timeline that, Microsoft Edge was used, right, from a user space. Obviously is some kind of phishing. User clicks on this thing in Microsoft Edge. Then we see, the system itself doing, curl.exe. That's where, we're doing some level of reconnaissance followed on by, assert util.exe to validate the SSL chain. And so this is telling us a story, right? It's telling us that the user got phished. It's telling us that the system is checking to make sure that the destination is available. And it's also checking for valid certification to go through and try to bypass other defenses, and then if we want to go deeper, we can go even deeper into that. We've got this one-click pivot directly into the CrowdStrike full host timeline, right? When you pivot into the host, now you can go into CrowdStrike and you can extend that time frame. And so we can see what happened before. We can see what's going on later. We can see if they're coming back with different tools. And we don't have to do these manual host lookups. You don't want to be, searching for the CrowdStrike agent ID. It just takes you there. But wait, Joey, Zoe, there's more, right? We also auto-generate the sophisticated Falcon Next-Gen SIM query. So it's got all the relevant connection characteristics. That query would take an experienced analyst 10 to 15 minutes to write. These are very complex, they're long. We give it to them instantly. So now they can hunt across their entire environment. All they got to do is remove the filter for the host. And suddenly you're looking for, these characteristics, these connection characteristics across any host in the environment. And this really brings a single detection into enterprise-wide threat intelligence.
This next gen SIM query, where do we see that exactly? Is that going to be auto-populated within next gen SIM, or where would we see that?
Yep, and under the show more processes,
Mhm.
right up top, you can see the run query in CrowdStrike.
I see
It's
that.
on the additional details. Crowd Investigate host in CrowdStrike brings you into the CrowdStrike timeline for that entity itself, and the query brings you right into the next gen SIM. And you'll see when you click on these, you'll see how advanced that query really is.
Gotcha, gotcha. That's awesome. So at this point here, we have a lot of context, we have a lot of information pretty much given to us automatically. So the next question for analysts here is, do I need to contain this right now? And can I do it from where I am right now? So we have something on the Vectra AI platform that automatically and natively stops attacks. How does automated response work on the Vectra AI platform?
Yeah, maybe in this time it's time to panic, right? So
Mhm.
because we've confirmed a threat, and when you do confirm that threat, every second counts. So traditionally, the analyst is going to have to switch tools, right? So they're going to navigate to the right host in CrowdStrike. They're going to initiate the containment, confirm it took effect. There's friction here, right? And especially with MFA logins and stuff, these things can take a little while to permutate. So with Vectra 360 response, we eliminate that. So what we're doing here is we're integrating directly with CrowdStrike's containment APIs. So when that suspicious network behavior is confirmed, we can trigger that host lockdown. We can do it automatically. You can do it based off of thresholds and scores and criticality, or we can do it manually, which is, being shown on the screen where we can actually click the button to say lock.
Right.
And, when we do that, we're going to trigger that host lockdown. And it's not a fragile SOAR playbook, right? That breaks anytime somebody updates the API keys or something. This is native integration. We're calling CrowdStrike's containment directly. We're getting confirmation back and we surface that status directly in Vectra that this host has been contained.
So in plain English, we just don't ever need to leave the Vectra UI.
Exactly.
Okay.
You know, we're already looking at the detection. We've got the process details.
Mhm.
We can understand the threat. We're right there. We can lock it down. No context switching, no hunting for the host in another console. We don't have to wonder if containment actually worked. And it's, for the architects, it's huge. They're not maintaining this brittle custom logic integration. It's reliable, it's maintainable, it's consistent, and it's purpose built. So now you can get faster response without any of that operational overhead.
That's amazing. Yeah. I mean, as an analyst, if I was an analyst, this sort of streamlined process, automated and streamlined process that like it's contained within one console, it just makes my life so much easier, not having to switch back and forth. I know we also have other integrations with CrowdStrike as well. So I want to talk about the CrowdStrike Next Gen SIM integration. When analysts need to do a deeper dive into the investigation and they want all their data in one place. So how does Vectra work with CrowdStrike's Falcon Next Gen SIM in that way?
Yeah, that's a great question. Not all threats are equal in sense of information that it provides, the breadth, the scope, and everything like that. Some of them are I don't want to say relatively simple, but some of them are a little more direct, and others are more obscure, right? And so that's where the SIM can really come into play, and where we stream our detection data. We also stream our network data, what we call the metadata. We stream that directly into Falcon Next Gen SIM using the ingestion APIs. So all that vector detection, the metadata visibility, it's all available inside Next Gen SIM alongside CrowdStrike's endpoint telemetry, their identity data, the detections, and the cloud events all together in one SIM platform.
Mhm. Mhm. So you mentioned earlier there's a run query and CrowdStrike option on when we were working on the Vectra AI platform. So how does that work there?
A simple button does so much. So when an analyst is looking at the vector detection, they're in that process correlation, they click on that run query in the CrowdStrike. We're auto-generating that CrowdStrike ngSIM query. It's
Mhm,
pre-populated, it's got all the relevant
mhm,
characteristics,
mhm.
and it's filtered into the specific host, the time frame, all the details around it. Huge head start. So that query would take an analyst some, 10 to 15 minutes just to construct manually. We give it them we give to the customer instantly. It's ready to run. As a matter of fact, when you click on the link, it actually runs the query and you get the results.
Mhm, mhm. So this is what you had mentioned earlier. All right. So that gives them everything they need then, right?
Yeah, it depends. How long is a piece of rope?
Yeah.
As I mentioned, some are very straightforward and some are more obscure. When it comes to obscure ones, that is just the starting point. Okay. This query, it's intentionally scoped to deliver, this very specific or finite detection context because it's filtered to the host, the time frame, those specific indicators. So when you want to go outside that realm and you want to go a little broader, you want to unlock that real power of having both CrowdStrike and vector data in that SIM. Well, what you need to do is you need to start joining tables. You can correlate vector detections, the vector network telemetry. You can join that with CrowdStrike processes, the execution tables, network connection events, maybe identity, maybe authentication logs. There's a lot of what they're called data sources. And so what you're doing through creating those and by navigating through the ngSIM is, you're asking questions like, you know, show me all the hosts that were suspicious and can we detect, things like credential dumping or credential theft or authentication attempts to privileged accounts.
That sounds really complex.
It is. It is. And that's what a level 3 security analyst does. That's why they're so hard to come by. There's a lot of tribal
Mm.
knowledge. There's a lot of writing very sophisticated queries, joining tables together, understanding data models, understanding schemas. And that has nothing to do with just understanding, what a threat is trying to achieve. That is just the tooling and the platforms, which it makes it incredibly powerful but also incredibly complex at the same time, requiring, very experienced analysts to work on this. The Falcon Next Gen SIM can analyze petabytes of data lightning fast, but, accessing that power does require a level of query expertise.
Absolutely. So that auto population from Vectra to Next Gen SIM is just monumental in that way. So much time saved, so much energy saved, right?
A lot of time, a lot of energy, and it's an excellent, in some case, bring you to the answer. In other cases, it's an amazing starting point.
Absolutely.
But some cases, there can be more. There can be more to understanding, the higher level threat, the breadth and scope of what's happening.
Mhm. Yeah, absolutely. So thank you for talking about the SIM integration. Now we want to talk. Now let's talk about the required expertise to write those queries. And we have our MCP server. We unify signals there. So how does wow, tongue tie. Oh, how does MCP change that equation of having to write those queries?
Yeah, this is a game changer. So we talked about how powerful the SIM integration is. You need that SIM integration, you need the data, you need all those fundamental data sources, which is excellent, but it requires that level of expertise to write those queries. And of course, the time it takes to go with it. So how does MCP really change that equation? So MCP, Model Context Protocol, it's essentially a natural language interface to, the same cross-domain intelligence that we just described.
Mm,
Both Vectra and CrowdStrike, we both provide MCP servers. So it's important. Customers don't need to build their own.
mm.
You deploy our MCP servers in your environment. You connect them to the LLM of your choice, ChatGPT, Cloud Desktop, and suddenly you can ask questions in plain English that would otherwise require these massive complex queries that we were just discussing.
Can you give me a concrete example of that?
Yeah, so let's take the same scenario we just talked about. Correlating suspicious network patterns with credential dumping, maybe some failed authentication. Traditional SIM, you're going to write that multi-table join. There's going to be multiple filters, conversions for transformations of the data sources across, at least 3 different data sources. It's a lot of work. With MCP, you can just ask, show me hosts where Vector detected suspicious network behavior and CrowdStrike flagged credential dumping in the same time frame. The MCP server is going to query both platforms. The LLM is going to synthesize all the results. And now you're going to get your answer. There's no query syntax. There's no table joins. There's no data model expertise required. All of that is done under the hood. You ask your pointed question and you get an immediate answer.
So all the same correlation work just through conversational plain English.
Exactly. So let's take a real example from our environment. So an analyst, they're investigating compromised host, called Piper Desktop. And, they may ask, can you list all the Vector and CrowdStrike detections from the last 7 days for Piper Desktop? I don't want that in a table format. So the LLM is going to go ahead and query both platforms simultaneously, and it's going to return a unified timeline. Vector is going to show the network story. We've got some RPC reconnaissance, perhaps, lateral movement, C2 beaconing. CrowdStrike is going to interject and show the endpoint story where, perhaps some Mimikatz credential dumping was being conducted. There's a WMI used for backdoor persistence and some process masquerading. The analyst might take that and say, okay, well, now what? What do I want to do with this? Map these detections to a single kill chain view. Something that, they're going to want to put together for the reporting. And LLM's going to synthesize that as well. They're going to synthesize it into this complex attack narrative. It's going to have initial execution, reconnaissance through LDAP, RPC, credential access with Mimikat, command and control establishment, lateral movement to another host, and then persistence through account manipulation for defense evasion through the process masquerading. We've just put that all into a timeline within the kill chain view describing the entire cross-domain attack reconstruction.
Mhm.
That's going to take a level 3 analyst, 30 minutes of manual correlation if they are phenomenal. It's usually going to take much, much longer than that. But MCP is going to deliver that in seconds through natural language.
You talked a lot about analysts, but I think you mentioned before there's some orchestration that could be done too.
Yeah, so what it does is it enables orchestration, right? So it gets interesting when you start talking about automation, SOAR platforms, SOAR orchestration, whether it's, commercial off the shelf or automation platforms you're kind of, building out on your own, they can make use of that same natural language interface. So instead of writing what would be these brittle API ingestions, right? So you create an integration based off an API ingestion that's very specific query response parameters. They're going to break, honestly, when things change, from time to time. And they're very rigid, right? But your SOAR, your automation platform, can ask the same natural language prompt questions that, the human analyst might be doing right from their chatbot. Get all high severity detections from the last hour across both platforms. Check if this hash appears anywhere in CrowdStrike, correlate it with Vectra network activity. Show me which hosts have failed authentication in Vectra, and have a privilege escalation in CrowdStrike. The human can do that, through the use of chatbots and the MCP tools. The SOAR orchestration systems can do that as well and synthesize the answers without, custom parsers or maintaining that correlation logic. So the time, the time to implement is significantly shorter than, custom API driven integrations.
So MCP is essentially democratizing that level 3 analyst capability, sort of like putting that into a more automated, streamlined way.
Yeah, exactly. The SIM integration is going to give you the raw power. You need the data. You have to get the data. It's got to be all in one place. You need to be able to do lightning fast queries if you know how to write them. But the MCP still needs to do those queries, right? So the systems themselves have to be developed for these, right? And CrowdStrike and Vectra develop our platforms to be able to support this, knowing that we need to move to this model, where make MCP accessible, to level 1 and level 2 analysts, right? They're not going to have years of query language experience. We need to make automation much more maintainable. We need to be able to do this very rapidly. And the way to do that is to exactly do that, democratizing that level 3 analyst capability, right? Allow the level 1 and the level 2 to do much, much more. Both approaches are going to solve the same problem, which is cross-domain threat intelligence. But what MCP is going to do, it's going to remove that expertise barrier, and it's going to remove that integration complexity.
Mhm. And if there's anything I know about security, it's that it's complex. So the removal of complexity is key to making things,
Yeah.
much easier for our analysts out there. So, Dale, this has been fantastic. Thank you so much for walking us through all that great information. But before we wrap up, can you give us like the big picture? Like, what did this all add up to for a security team?
I think the key insight here is that attackers don't limit themselves to one domain,
Mm,
right? They're going to blend endpoint techniques. They're going to blend it with network movement. They're going to try to evade detection, malware on an endpoint, beacons to a C2, lateral movement, exfiltration, data across the network. So what we've built here with CrowdStrike is a complete investigation workflow that mirrors, you know, how attackers actually work, right? You need to get immediate asset context. You need automatic process correlation, that answers what caused this, and you also need the one-click containment so that you can stop it. You do need SIM integration for deeper, well, okay, it's not just deeper, it's deeper and it's also broader or wider analysis. And then you need MCP for natural language investigation to really, really speed things up and do this across, both platforms without needing, purpose built training and expertise for it. So then result, an analyst spending less time hunting for context, more time stopping threats. Investigation time, is going to drop, from, what will be 15 minutes, 30 minutes to under 60 seconds. And that's going to compound across every detection every day.
yeah, absolutely. Well, this absolutely has been amazing. Thank you, Dale, so much for your time and explaining this to us. Audience, what are you excited about? Excited about? Is it the MCP server? Is it the EDR process correlation? I'm excited about all of it because, like Dale said, this
All
is
the above.
all the above. Yeah, because it's taking, yeah, like you said, 15 to 30 minutes into 60 seconds, even less. And if there's anything that I know about us is that we're all super busy and time is very valuable. So yeah, so audience, let us know what you think in the comments. We're happy to read it, read your comments, respond to them. But thank you so much again, Dale, for your time. This has been fantastic. And yeah, thank you all.
Oh, my pleasure, Zoe. Absolutely. Thank you so much for having me.
All right, see you next time. Bye bye.